Hai, jom. Sembang AIoT again. A very good afternoon, good morning, good evening. If you are watching us in any part of the world, myself, CC Lee from ExamTech, and then we have 𝐀𝐮𝐬𝐭. We have 𝐀𝐮𝐬𝐭 here. Sorry, there is some delay and we have some technical issue that we are not able to do it on time. Yeah. So I hope this. Oh, by the way, can you hear me? I hope you can hear me well. Is my mic okay? Yeah, I suppose so. My mic is okay. What about you, 𝐀𝐮𝐬𝐭?
Yeah, then it's okay.
Can you test your mic?
Yeah, already turned on.
No, you speak and then we can see that the thing is okay. Yeah. So today we have beside me and 𝐀𝐮𝐬𝐭 also we have Amil helping us, and then we have Chen here helping us to do this live video. So one day we will show you how at the back how they assist us. Okay. So how are you today? What is the hottest topic today, 𝐀𝐮𝐬𝐭?
Today, I think still same as last week.
Still same as last week. So we are still having this Pilihan Raya Negeri. So tomorrow is of course tomorrow is holiday. Yeah. So tomorrow is the election day for the Negeri. Okay. But Monday, I think if let's say this, I see the news, there may be a holiday. if okay, if some of the party win or something like that. Okay. So okay, without further ado, I would like to just talk about this last week. I think last week we share about what last week we are sharing about this smart manufacturing. Still, again, this week we are going to share the same smart manufacturing, but on another level. Yeah. So we were talking about some device or gadget that you can use. You can plug into the machines, then you can build your OEE and so on. Yeah, that is first level. And then once you get the data, because at the time we didn't show you anything, right? Today we are going to show you later, but more at the end of the show. I'm going to give way to 𝐀𝐮𝐬𝐭 to do some his part first. Usually I will present more on the IoT side. Now 𝐀𝐮𝐬𝐭 will do on the AI. But before that, 𝐀𝐮𝐬𝐭, I'll just take several minutes because it's good that every time I think it's good that I would just bring some of the legacy thing behind, from since 1990 something. Yeah. Since we ExamTech, as you know, we are specializing in industrial computing. Also, ExamTech is one of the world-leading design manufacturing company, especially in the computing. Especially in the 1990s, yeah, most of the field or industry that we are targeting or we are working on are mainly automation. I think a lot, dealing with automation because that time is doing the industrialization. Yeah, that time is industry 3.0. Yeah, 3.0 talking about automation. So during the time, there is such a thing called PC-based. There is a PC-based automation. The automation has migrated or has been have been used in this industry. It's switching from a PLC-based to a more PC-based kind of thing. Yeah. So that was a time that we were working on. That's why I want to share with you. I don't know whether you can see or not. You can see this one. I want to show to our audience. Yeah. So I don't know whether you can see or not. Maybe it needs some focusing. This is actually a Cyrix. Yeah, this is basically a Cyrix. I don't know whether you guys seen this one or not because when I was doing some clearing, I saw this one. This one is 1990 something. Yeah, during the 1990 something. And then we have this another processor. This processor, as you know, Cyrix, actually the manufacturer of the Cyrix is during the time is the VIA. Yeah, it's from Taiwan. And then this is the AMD. This is the AMD microprocessor. It's also very old. This is basically a 586. Yeah, it's a K6-2. It's a very old processor at the time. Of course, there are basically three players at that time. That will be the Intel processor. Yeah, it's very old Intel processor, which is also this is slightly newer. You know, I try to get something like that because last time the Intel processor it looked something like that, but it has a Intel printed here, white color. You know, same color as this light gray. You know, that is a 486. You know, the 486. Yeah. So having said all this, for some of you who are old enough, you know, or for some of you who are still young, haven't seen this one before. Hey, by the way, you know, have you seen this one before?
No.
You've seen it in my office. You've seen it in my office because I put there, I want to frame it. These are 586. But way before that, if you look at this, these are all evolved from the Intel 8088, yeah, 8088 and 8086. During that time in the test lab in the college, we used to do the microprocessor system design. So our lecturer will ask us to refer to one of a very thick book. You know, that is Intel 8088 and 8086. Inside there, they talk about the whole architecture of x86 processor, how it's being designed, and then how you can use this processor to expand, yeah, to expand the especially your RAM, you know, your storage and things like that, yeah. So a lot of things deal with this assembly language during that time, yeah. So there are two very important interface that I still remember. During that time, we were talking about the serial interface called UART, UART. UART is one of the serial communication, which is last time until now. Okay, our serial RS-232, 485 are basically based on this architecture. So the other part will be that UART is called, if I'm not mistaken, that one is called PP. It's not PPI. Yeah, it's there's a name for it. Okay. Then the other part is the talking about parallel bus. You know, parallel bus. At that time, after that, they were used. It's been used in the concept has been used in all the printer port. Yeah, that is how when you build a PC, a printer port running on parallel, and then serial bus, you know, used for mouse or digital input device or pointing device. You know, these are all running under RS-232 serial interface. So that is very important concept actually. You know, I still keep some of the notes. You know, how all this thing is being interfaced from the microprocessor side. You know, especially based on the 8088. So after that time, I think 8088 is way 1980 something. Yeah, we are just talking about in 1990 something. These are the processors that appear during that time. Yeah, these are the processors appear. We have this 386, okay, you know, from 8088 you have this after that you have this 286, which is is practical lah. You can buy one, but in between there some other models also came out from Intel, I think. 286, and then after that there will be the 386. 386 still you can still buy in the market during that time, 1990s, you know, 386 processors. And during that time also, some of these device come up, you know, 386, 486, 586, and then come to a Pentium, yeah, Pentium Pro. During that time, it's 1998 or 99 already. Yeah, Yeah, 19.8, 19.9 already. Pentium Pro. Right after that, I think in between that, they faced some issue. I think if we can trace back the history, it's something to do with the floating point processor. You know, because in order to process all the engineering data, you see, right now, today, we are talking about AI. We require a lot of this calculation, GPU, all those things. Previously, we don't have all these things, It's based on this FPU, a floating point unit, So they do all this kind of very fast calculation inside. So I think during that time, they have some issue, it's called some bugs, during the process. I think it jammed for a while. Then after that, everything has become smooth. Then you can have right after that, you have a Pentium. After Pentium Pro, you have a Pentium 2, Pentium 3. That is where it's all started until now. Yeah. So I'll just quickly summarize some of this history. It's called history. It become history lah. 1990 to 1990, 2000 is about 20 plus years lah. Almost 30 years from this point of time. So yeah. So these are the things. So during that time also, if you can see here, this is a so-called a PC104. This is a PC104. I don't know where. Okay. So this is a PC104. This PC104 is very useful, especially when we talk about the this industrial automation. Why is this so important during that time? Is because these two, see, this is a processor board, okay? And then this is the I/O board. That's why I told you just now a PPI, if some of you who recognize the part number 8255, because I can't remember, I can't forget lah. That is during my time when the PC-based interface is being used, the 8255. 8255 has got 3 ports. Each port has got 8 bits. That it will make up this 24 bits. For this card, this board. So some of these people, I mean, some manufacturer take this opportunity to design a 48 board or 48 I/O board, 48 point. Then what they do, they already designed this PC104. This PC104 is actually, why is it called PC104? Is because it has total of 104 pin here. This is basically ISA bus. Previously, right now you can't see any ISA bus anymore. But in our industrial PC, ISA bus still exists. Yeah, so it still exists. So by piggyback onto here, in fact, I tell you this is a very old thing. But if you go to some places, you can see this system running. Especially in some power plant, you can see this thing running. Okay, so by having this connection, this type of connectivity is very strong. Yeah, so it can withstand all kind of vibration. Whatever how you vibrate, all those things, it won't. The contact is always good. Not like this time. Now you plug in USB, you try and see, you put on the car, and then run, the thing become loose. This type of connectivity or this kind of connection is always very firm. Yeah. So that make up the first chapter of PC-based, I think, under 80386. That time has made a lot of this automation possible on the PC-based platform. Yeah. So maybe in the later chapter, we talk about what are the operating system. I always talk to Amir also. What was the operating system that you? So in order to be in the PC-based field, or some of you who want to trace back, you are still always welcome to come and we talk about this. Of course, right now it has become, you can have a Core i7, talking to all different I/O with a very, very high speed. Yeah. Last time is purely under running DOS. It's a batch processing. It's not even a multitasking. So I'll reserve this part. Maybe OS next time we talk about how this OS evolve. So yeah, so that one is this part. I'll just end with this. Of course, we will continue from here. By the way, thank you for watching again. This is Jom Sembang IoT's channel, all the way from Kuala Lumpur, from Petaling Jaya, Malaysia. Yeah, from Petaling Jaya, Malaysia. So I will just leave this part to Ken Leong. Ken Leong, you want to share something about some of the findings, yeah, on the AI side, before I continue on the smart manufacturing on the OEE, the display, cloud, and so on. Okay, now maybe you can continue.
So this one, last week I found this thing, and then I think this there's some history.
This is also got some history, yeah. Okay.
So we would like to ask Mr. Lee, what is this for?
Okay. Yeah, this panel, I also didn't know. Suddenly, Ken Leong just this one we want to just show to some of our audience. This plate, actually we have several, 3 or 4 pieces. We have
four pieces.
3 or 4 pieces. 4 pieces.
Set.
We ask those are people who repair magat one, we ask them to make metallic, show me the metallic, because you know why? During the time, this one about 4 years ago, not so long, 4 years ago. This part, we wanted to do some vision AI on certain application. So we want to build a sample to do some proof of concept. Yeah, that time is doing the proof of concept. That's why we asked. I come up with my own money to pay a few $100 just to get this stupid four pieces of the metallic plate. Yeah,
I think that time is still, before MCO. And then I think Mr. Lee.
Before MCO lah.
Yeah, before MCO. Yeah. And then this task was assigned to one of my classmates.
Oh, okay.
And then my classmate asked me how to solve this problem.
I see.
And then if we go back to 3 or 4 years time before, at that time, the AI just started. And then at that time, the thing very famous is the object detection. So I recommend my friends, my classmate to use the YOLO.
YOLO.
I think that time is YOLO V2 or V3 only. Now already YOLO V8 already. So he used the YOLO, and then I think he spent few days to draw the bounding box, to collect the data set. I spent some time to do it. And then today when I look at this thing, and then I asked one of our colleague, Amil, using our new software to handle this kind of task, and then he managed to get it done within 1 or 2 hours on it.
Okay, wait. You say use a new software. That means previously it was you use a very conventional way to build the AI.
Yes.
So right now we actually using the one that you were doing. You were working on that thing, right?
Yes.
On the unsupervised deep learning, is it?
Yes, correct.
Oh, you use that to do really? I didn't know.
Yeah,
and also I didn't know about that part of story. Can you just share to me? Okay.
Yeah, that time is using supervised deep learning. Therefore, my classmate need to, for every defect, need to label it. And then you also need to create a lot of different type of defect. But today we don't need to create so many defects already.
I see.
In fact, I need a good sample, but I only have one good sample. But in this case, we still manage to train the unsupervised deep learning model to perform this task.
Yeah.
So what the good unsupervised deep learning model do is, it only require a good sample. So since I only have one good sample, doesn't matter. The board is so big, so I capture a small portion, and then another portion I capture image again, and then we repeat it. And then since for the good sample in this case, actually you cannot see any difference also. So you can capture at the same region, and then repeat it for 100 times. After that, we start the training. So now I would like to show you our result.
Okay, we can share
this
from the
one
other
is
side.
our setup. And then we go to the software side. Our tab. this one, another one. Yeah, okay. So this is our new software where it performs the abnormality detection. So we consider all these defects as anomaly. So no matter it's which type of scratch or even dented, also able to detect it. So compared to I think 3 or 4 years ago, some of the defect might not able to, we cannot able to successfully detect it. There might be some false detection or we miss the defect. But now by using this software, we don't have this issue anymore because it's based on the, how to say, it's up to the pixel level already. You will detect which pixel contain the anomaly.
But I think the sharing slide is not very clear lah. How to, is it clear? Oh, okay. These are the yeah. During the time, I think the objective is to find some defect on the car, the automotive car manufacturing what you call the panel or the door or the whole car chassis are basically, after painting, to detect some of these flaws, after the painting process. Yeah, that was a time. Of course, those are created one, we created some of the thing. Yeah. Oh, okay. So unsupervised become, any defect also you can let lah. Yeah. Okay.
So if there is new defect come in, we no need to retrain the model anymore. Be able to detect it.
So what kind of application that you can do for automotive like that? What are the challenges here actually?
Okay, the challenges here is we need to control the environment lighting.
Okay.
If the lighting change, it might cause some problem.
I see. Okay. Yeah. So the bottom one is how we set up lah.
Yeah.
As a just to showcase only lah. This one is not an industrial, just to showcase that part. Okay. So yeah, that is the first chapter of the. Is it done?
Yeah, it's done.
Oh, it's done. Okay. Thank you. Thank you. Amil. So this part, yeah. Without Ken Leong telling me all the history also, I don't know, at the back actually there are so many, because during the time also, yeah, during the time also I didn't know that
That time I still study.
I also didn't know that you are working at the back on this part. So coming back, last week we were talking about some this smart manufacturing side. Of course, just now what Ken Leong shared is also one of the application in the manufacturing process. Of course, there are a lot of different application that you can apply in this field. And by the way, this morning we have. This morning I attended this MDEC event. There is a Pemangkin program. Yeah. So in this new setup or new program, government is actually helping the industry to, especially right now. From what I see, there are two areas which the government is putting more focus in. One of them is the agriculture, digital agriculture. Yeah, the smart agriculture, basically, digital agriculture. And then the other one will be the digital city, smart city. Yeah, these two parts. Why that is very interesting. In fact, you talk about this food, food chain and agriculture. If with the technology, or part of manufacturing, maybe we have time. We can also talk. We can also chit chat something more about digital agriculture, digital what they call the digital cities, smart cities, and so on. Yeah. So so these two focus actually, I just want to highlight this part. Digital agriculture is very, very important. If the technology is able to help to increase the productivity, let's say, yeah. So you know, the effect is very big. You know, the chain effect is very huge. Yeah, that will actually help in our economy and also help the farmers. You know, different technology, they can have a good productivity. At the same time, they can increase their income. So, and then at the same time also, with the more productivity, we will be able to reduce the import on the food and so on. Oh, that is huge. You know, one of the example they highlighted is one of the speaker I think from MDEC. You know, that's very nice example. For example, you eat nasi kandar. You know, what are the ingredients? You know, from the nasi kandar, from the rice, from the chili, from the all this pepper, all this thing, the you know, all the recipe. So mostly, if country is able to, you know, increase the productivity, especially right now a lot of people planting the chilies. Yeah. We also have one customer who are working on this chili farm. So they are using some of our device to do the fertigation, you know, automatic fertigation and control monitoring. So if they are able to use technology to increase that part, you know, so you see, you know, how much chilies Malaysian like, you know. So actually we don't need to import anymore. Then increase of the income of the farmer, you know, that is fantastic. The chain effect there, that only two part of it. I think there are many more that will be affected. That is very, very, very interesting. That's why in the near future, I want to talk to you, Zhen, how we can make use of some of the AI and IoT, you know, in that area also. You know, maybe we can also build some proof of concept. Okay, so coming back to the manufacturing side, last week I think we shared some gadget. We share some device that you can install at the machine, you know, calculating the overall equipment efficiency with the data. Immediately you know, whether you are running good, bad, or losing money or earning money, all, you know, can be tabulated from there. So that's why that will lead us to this the second topic of how this data can be visualized on the cloud level or become more transparent. Yeah, so that a lot of decision making can be done there. Yeah, so I just want to show you this part. How I show? Can we show the display? Yeah, Kenan, maybe you can help me to just explain this part.
Okay, so this one is a HMI, and then we are connecting this thing through the Wi-Fi to pull the data from our mobile device.
Okay, you can see the round one. I think not very clear. This is one of the ExxonTech HMI touch panel. Is you can install this one at the front of the machine. So by having all this data, you can see this machine OEE live. You know, whether good or bad, you know, how we want to improve, you know, that can be visualized from here. But all this lettering you cannot see. The round thing one is actually the first part is the OEE.
OEE, quality.
So this set of data is easily at this level. Okay. So it's okay. I think the connection has some issue. So never mind. You change back this one. Don't pull anything. I think you unshare this part. Pull out you unshare this part and pull out. So I think, is it still connected? I think it's disconnected. Is it connected? Huh? It's connected, right? Okay, sorry, because we thought the thing is, we got a prompt there. Seems like it's being already disconnected. So we just uncheck this part. So that is the HMI, or you can use this one, like last time I showed you, the gateway headless. That is with head, meaning you can see all your result, immediately locally from there. Okay, the whole integration like that, if you're having the display like that, you can also share the data to the local SCADA. Yeah, last time I mentioned also local SCADA. If let's say we have this opportunity, we'll show you again. And the other part would be the cloud integration. This unit, how is this data being published? It's published to the cloud, right?
Yes.
So it's connected to internet. It's actually published to the cloud. You can see the screen, on the right hand side, on the left hand side. Okay, these are all simulated data lah. The OEE go until 288%, which is already not correct lah. Because we have some simulated data here, some what do you call the availability? 99% availability, also 300%. No, I think this data is wrong. We shouldn't have a two set of ability, but doesn't matter. This is how you can visualize your data lah. Yeah, we just want to show you how you can visualize the data. Yeah. So previously we were doing some testing during that time. We do some update of firmware in one of the module. I think some data has been screwed up or something like that. So that was the thing that we were trying to fix just now, not able to get. That's why we got a delay. So, okay, I think that two things, after getting the data over the cloud, you can, over the cloud, there are three things you can do. What are the three things, What are the three things that you can do? We can visualize, of course, like what did you do here?
We can have the alert.
We can send an alert. Let's say your productivity, let's say of course OEE become 288%. Usually boss will be laughing like want to die but that one won't happen. Okay, that one won't happen. But if let's say they're talking about quality, very good, 96%, not bad. The availability, wow, 90% also. The what they call the OEE, very beautiful. So you don't need to do anything. But suddenly, let's say availability go until in the afternoon, it become 50%. Then that is a time maybe you can send an alert. You can configure to send an alert. That one can be just on the fly. You can configure and then you can blast out to the person in charge. Why this availability is so low. So this is how the OEE is being tracked. Okay. So the third one is what?
We can download the data.
Yeah, we are creating some historian. So just want to highlight this point. Sometimes creating this kind of data just for you to view it, there's no meaning at all. But if you keep that and then you build a history of data, in future, of course, in the whole OEE tracking is not only about these three big things, but internally they are, why the machine down, down for so long because of what, yeah, and then the quality reject. What are the rejects? Category of different rejects, and also the performance. Why the performance drop? Because of what? The machine status. Is it because of the short of material, no material, or machine always down, things like that. Those things can be used, at the first level. You can do judgment, you can do some decision making based on this data set, of course, But if we are still trying to find out what are the AI model that available, if you kept all this data on the cloud, we can in future we can build those things, on this some AI model is able to train to do some optimization, not optimization. That one is to do what? not optimization. That one is yeah, maybe you can say it's optimization. What are the settings that you need? What are the contributing factors that you should take care in order to have what kind of OEE that you are expected? Yeah. So that is very important, right? Yeah, of course, that is very important. Yeah. So I think we have, I think I've covered some of this part. Do you have anything other to say? No. So we would like to thank you very much for watching, and then please SSL, share, subscribe, and like, if you like our channel. And then sorry for the delay for today. We supposed to kickstart at 4 o'clock, but I hope some of you who have missed it, you are able to connect back, and then you can watch this one, for your reference. So I think we would like to thank you all again for watching. We will see you next time. As yeah, just before that I forgot. We have this. Me and 𝐀𝐮𝐬𝐭 always we are doing the training, digital transformation awareness training. If you are interested, you can see this from this barcode. We have this QR code here. Do you have QR code? Yeah, this QR code you can scan. You can find out more about this program. A one-day IoT and AI practical hands-on training, which is also a HRDC claimable. You can take this opportunity, and then we have this early bird discount. Our next coming training will be on the early September. We have put up a date of early September. If you send the QR code, you can find out more. And then also we have another event, a very special event in Malacca. I forgot, almost forgot. Yeah, I thought we were supposed to talk to you guys about this one. Malacca, there is in University Technical Malacca, Technical Malaysia. Malaysia Malacca, okay. There is an event organized by Dr. Lim, Dr. Lim who came to our this show the other day. Yeah, Dr. Lim. So he's basically organizing a event. We invited a heavyweight, from UK. Basically he invited Dr. Bala, Dr. Bala. So he's going to share with us on the data science or AI in this manufacturing, and also large language LLM. They are sharing about ChatGPT or those things. So if you because the event is in Malacca, very short, 2 hours. So basically, we can call it a webinar. Not webinar. It's a seminar. Yeah, it's a seminar. I don't know whether Dr. Lim can make this one live also from there. Yeah, why not? If we are watching, yeah. So if you can, if you want, on the left-hand corner here, we have this QR code. You can also sign, especially for those southern part. I don't limit you from anywhere lah. If let's say you are from Thailand also, you want to come and listen to this case. Basically we are going to share you live demonstration. Yeah, we are going to share you live demonstration on some of the AI thing. Yeah, and also some IoT stuff lah. But main thing is this super heavyweight speaker from UK, Dr. Bala. So he's actually from Databricks. Yeah, from Databricks. So yeah, he's going to show us a lot more things there. So that's one thing. And also, we have a lot of these events are very busy. On the 22nd, on the 22nd, we have this webinar on this Jomtech Digi Hub. Mr. Mark will be from Taipei is going to present to us. Of course, we will be joining in. So I hope you guys can follow us at the event, because that part we are going to talk about some of our 𝐀𝐮𝐬𝐭, some gateways, some boards that allow you to extend further on the development part of it. Yeah, especially when you do Node-RED or you write Python code, you want to access to a deep level of the our gateway or boards. We offer API. We offer, I think Redfish last time. Last time this Mark was telling what Redfish is. They have this REST API to make calls, is it?
Yeah, can communicate through the REST API.
REST API. So you can use that to communicate through the REST API. So that is a 3 event. If you're interested, please do click the QR code. Yeah. So with that, I think we just want to conclude today's session. Every time, we believe the technology is to amplify your efficiency. With that, we want to conclude this show. And thank you very much, and see you again.